Okay, good evening, everyone. I believe you all can hear me. From our previous class, I said I was going to drop a video, but I later on changed my mind. This class is going to be more in depth, so I'm actually just waiting for other persons to join the call. And this is what we were doing in our first class, which, sorry, second class rather. This is what we're doing. And I'm going to start over again from the beginning and guide you on how to do that. So those of you that were unable to participate in the class on Wednesday, you still have another opportunity to learn everything from the beginning. This is the Aspen Hysys software. The first thing we need to do is to add our component list. I'll click on add and select the components I want to add here. I have methane, ethane, propane, and ethane, methane, ethane, propane. Okay, methane, ethane, propane. We also have and ethane. Um, we have M ethane. We have one ethane and one butane. I'll add these ones. Type 1 butane here, which is this. Click on add. And then we have one three butadiene, 1 3 buta, 1 3 butadiene. Click on add. Excuse me. And we have successfully added all our components, which you can also call the elements. And that's basic. If you want to carry out a normal, maybe chemical equation, you
Yes, sir. You
you
are not
list out the
audible.
elements,
You
but
can't
in Aspen Hysys
hear
we
you
call
so
it
well.
components. Okay. Well, how about now?
Yeah, you can hear
How
me.
about now? Okay. We have successfully defined our components. Here you can see SRK, equation of state. So that's the thermodynamic property we are going to be using. I'll click on fluid package, click on this, and I'll scroll down to SRK, still coming up. Yeah. So this SRK here, I'll click on it. The moment I click on it, I've defined my fluid package. Then I'll come to my simulation window, which is click on the simulation tab here at the bottom.
Yes, you are not audible.
This is the
Like,
first
I don't
step.
know if it's from my
The
side.
first step is to,
I think it's actually from your side.
okay. I think maybe you can increase your volume because I know I'm audible. Okay, the first thing you need to do is to define your component list. After that, you define your fluid package. You move to the simulation window, you select your material stream, and from this, material stream is named as feed. We'll zoom this in a little bit. You can see this is named as feed. Okay, I will, give this thermodynamic properties, which is my components. Okay, we have this is defined in mass flow rate, which is pounds per hour. I'll double click on this, change my stream to feed.
Yes,
Can you
can
guys see what
see.
I'm doing?
Yes, I can see.
Okay, okay. So change this to feed. The next thing I'm going to do now is to specify the temperature. You can see the temperature here is 85. We have also 100 psia. I'll come to temperature 85. Click on this from Fahrenheit to degrees. 100 psia. Click on enter. Like I said, when in the previous class, when defining your properties, you see, you always see this yellow strip here. Whenever it's showing that yellow strip, it means you haven't fully defined the properties. You understand? Now it's showing you unknown composition. I'll click on composition, click on edit, and click on mass flow because that's what was given from this mass flow. Then I will define all this. So we have 50, 100, 700, type 50, 50, we have 100, we have 700, we have N butane, um, 850, 870, 1176, we have 870, we have 1176. Then the next thing we have is 5130, 5130. Hit enter, click on OK. Now you can see that it has changed to green, meaning it is fully what defined. So if yours does not change to green, it means you haven't defined, you haven't given Aspen Hysys the minimum properties it needs to do its calculation. And like I said in our previous class, all these lettered in black are what Aspen Hysys has calculated based on the figures, the variables you have given to it. And what we can change here is only what is in what blue. So we can change the temperature, we can change the pressure, we can change the mass flow rate because those are the things we gave as input. And also you can see
A little
this
bit slow
our feed.
because
Our feed
I'm
is
trying to
now
follow you as you are
green.
inputting the data. Yeah.
You said? What did you say? Okay, so
Can you hear
from here you
me,
can
sir?
see that I just added this material stream, which is one.
Hello?
You can see the color.
Please, sir, can you be a little bit
Yes,
slow?
I
Some
can
of
hear
us are
you.
trying to follow you as you are inputting the data.
I can hear you.
Can you be a little bit slow? I'm trying to follow you.
Okay, no problem. But
I hear you. I can hear you.
can you hear me? Can you hear me? Yes, I know.
We can hear you, but it's
I'll
not
try my possible best. But
much audible.
yeah, I'm also doing this so that um just calm down. The videos are going to the video is going to be available. Everything is recorded. You are still in the Aspen Hysys group. We have a time frame, and I want the class to be as interactive as possible. So for this, we have two feed stream here. We have feed or two input stream, input feed one and another input which is feed. You will see that there's a color difference between feed and one. The reason feed is blue is because it has been fully defined. It has the correct thermodynamic properties, and this input stream, which is just one, doesn't have complete thermodynamic properties. Okay, the next thing I'm going to do from here, um, our knowledge in chemical engineering. We know that our pump, this pump now, there's a mixer here because this is basically a recycle stream coming back. There's a mixer here, which this mixer goes into this separator. We have one equipment pump, we have another equipment mixer, we have another equipment um, yeah, mixer, separator, and pump. We'll add them one after the other. And okay, the first thing I'm going to do is to add my mixer and add another material stream. I will name this mix out, mix out. You can see that is the color is on light sky blue. Double click on my mixer. Then we have our inlet stream here. I'll click on my feed. I have my outlet stream. I'll click on this. Now you can see that the bottom here is fully defined. I'll close. Okay. So you can see that this whole thing is what fully defined. I'll keep a mixer here which is not defined, so you can see the difference. When your mixer is like this, red, know that, or any of your equipment, know that it's not defined. I have my feed. Next thing I'm going to add is my separator. I'll come to separator, look at separator here, click on separator and add one separator here. Okay, for this I will have the top product and the bottom product. For the top product, I will name it vapor and we have product. Double click on this and come here, name it vapor. Double click on this, come here, name it product. Okay, I'll double click on my separator, come to the input. We have the inlet stream, click on it. I need mix out. That's what is going to enter. You can see it mixed out. That's what is entering my separator. Click on the vapor outlet and product. So you can see that um, my separator has also been fully defined. Yes, you can see that here is also what fully defined. Then there's some other thing here. I'm going to drop it as a question. Now you can see that we have our product, which is this. How do we get this other stream that is going to the pump? Can somebody answer that question? This stream that is going to the pump, because from here now, our separator, we can't have two outlets. We have only one outlet. So how can we add this other second outlet that is going to go to the pump? Who can give me an answer to that? This outlet that we go to the pump, can give me an answer. Oh, shit. So I was asking a question before
Yes, I
I
can.
got logged out.
Yes, I
Can
can
you all
hear you,
hear
sir.
me? Okay. So my question is this: we have this is where we are. We have gotten this. How can
Hello,
we
sir.
get
Please, sir, your
this
screen is not showing
output
again. You're not
stream
sharing it with us.
that is going to the pump? Okay. Thank you. Okay. So this is what I'm asking. This part that is going to the pump, this stream that is going to the pump, how can we get it? This is where we are now. We have gotten our product stream, we have gotten our vapor. So this part that is going to the pump, this stream going to the pump, we have gotten our product. This stream going to the pump, how do we get it? Can somebody say something? Just you must not be correct. I don't expect you to be correct. Just say something. So everyone here is basically an engineer, and majority of you are in chemical engineering or studied chemical engineering or something related.
I think we create a return path to the pump on the separator.
Okay, someone said a return path. Which other person has an idea for a
I think
contribution?
it's like the waste from the bottom that needs to be recycled back. So we use the pump to recycle it back to the separator.
Okay, that's also a good solution. So I'm dropping the exercise. Um, I'm dropping the attendance. So this is your Um, the code is extractive distillation, which is what is on the screen. Extractive distillation. You can copy it, write it down somewhere. And I'm also dropping the attendance form now in the chat box. So we have 16 persons on this call. Okay, let's go back to what we were doing. So for this, what we need to do is to, I'm trying to look for something. Six point four, diagram 6.4. Just give me a minute. Okay. So in order for us to get this, what we need to do is to specify few things. And one of those things we need to specify is we need to introduce a splitter here. We need to introduce a splitter that we split the product coming from our separator. That was what I was actually expecting. Um, so I will rename this to sep out. This is coming out of our separator. So from our sep out, I'll use a um, I'll come to piping and hydraulics, click on separator. That's a T. Next thing I'm going to do, I'll select this and select this. This one, I'll name it product. This one, I'll name it to pump. Double click on my T. What is coming into my T is my step out. What is going out is my product and to pump. Wait, I'll first of all delete this. Now you can see that um, this whole stuff is defined. This whole simulation is well defined. I need to arrange my icons. I'll click on the icon I want, come here to customize. Okay, flow sheet modify. I'll click on flow sheet modify and rotate this way. Yeah, I've rotated it. Same thing applies to my T. I'm also going to rotate it this way. Make sure that my simulation is very easy to understand. Rotate this also this way. So I told you that if your incoming, can you guys see my screen? Oh, Uh, can you see my
Not
screen? Can you see my
not
screen?
yet, sir.
You can see my screen.
You can see it. I can see it now.
Okay. Okay. So for this, make this bold. Um, okay. Now, looking at this, we know that this simulation is fully defined because everything is on blue. But you know that this our T, some portion needs to come to the this pump out. I'll click on it. Click on this pump out. The moment I do that, it says unknown split. So what it means is when using your splitter, we have a source or an input, which is our sep out. That is what is coming from our separator, the output of our separator. And we have a T, which we know what a T is. A T has two outputs or two split outputs. What Aspen Hysys is telling us is that it wants to know what percentage or what split fraction is going to the product and what split fraction is going to the pump. So if 100% is coming out, 100% is entering into this into our splitter, what fraction is going to the product? Are we recycling 30% of our separator out or the bottom product? Are we recycling 50%? Are we recycling 40%? Are we recycling 90%? Are we recycling 70%? We need to specify that. That's why Aspen Hysys is telling us that um, this simulation now has not been solved. I'll come to parameters. You can see what I have here. Products, we have products and pump. All I need to do is to say zero point 0.7 as the zero point 0.8 rather as the product of 0.7. The moment I do that, Pen Hysys has automatically calculated the flow ratio. So if I say zero point 0.7 is going to the product, so it means 70% of what is coming out from sep out is going outside. We are taking it as our finished product. Then 30% will be recycled, or 30% is going back to the pump, which will be recycled back to the mixer. So let's look at that. You can now see this is now fully defined. I'll come to pressure changer and click on pump. Click on the pump here. Click on this and rotate it. Okay, flip horizontal. And click on this. I will name this as pump out. Pump out. Come on, I need to.
Okay.
Okay,
Good
somebody
evening,
is
sir.
asking a question. Ask a question.
Thank you. So, I I noticed that when you just added the
Yeah,
pump
good evening.
representation, the pump, that is the P100, you rotated it. I want to know how you were able to rotate it.
Yeah.
Yes, that's my question.
Okay. I'll click on it. Watch my cursor. I move my cursor to the top. Okay. Top. Watch my cursor. I'm moving my cursor to the top left corner. You are going to see rotate. Okay. Now I'll make sure you are on the flow sheet. Where everyone is the home tab. Move to the flow sheet modify, flow sheet slash modify. Click on it. Then come down to this rotate. But first of all, make sure that you have clicked on the object you want to rotate. You click on rotate or flip. So I'm going to use flip because this was how it was previously. It was facing this way. I'll click flip horizontal and you can see it has changed to um, this form. So the same thing applies if I click a material stream now, click on it. You can see that the material stream is facing this direction. I'll click on it and click flip horizontal and it has moved this way. So I guess that answered your question, right? Has that answered your question, sir? Can you all hear me? Can anyone hear me?
Yes, I can hear you, sir.
I can hear you also.
Okay. I'll click on my pump. The inlet is pump no to pump, yeah. Then out pump out. Now it says required energy stream. I'll use key Q1 and it's also asking me for a duty. I'll come to parameters and now pressure ratio. This pressure is what 100 psia. The pressure here is also 100. And this, remove it. So for this, my pump, um, so from this, my separator, the temperature here is 5 degree and the pressure is 25 psi. Most times when I've noticed that most times when I change the pressure here and temperature, it tends to make Aspen Hysys not calculate it properly. So I'm going to worksheet. Come here, just give me a minute. I'll double click on my mixer and add another product, which is pump out. Okay, no, for this. Now, when you want to add a recycle stream to Aspen Hysys, you come to manipulators and click on this. This is called this is a recycle stream. Click on it, double click on that and select pump out. Then I'll type recycle. Click on this and select recycle. Yes, it has given me an error which I now need to fix. I'll double click on this, my separator, and this is where I need to set few things. From this, we have our separator has its temperature at 5 and 25 psia. That's what I'm going to set here now. My sep out, this temperature is what? 25. And its pressure is sorry, temperature is 5, pressure is 25. Pressure is 25. Temperature is 5. And properties, composition. When someone wants to join, I need to delete this recycle stream first. Yeah. Okay. It has calculated it. And where we are having a little bit of issues is in the pump. I'm going to come to parameters and pressure ratio. I'm going to use a simple pressure ratio. Just add 2. After I've done that, click on this and recycle. So you can see that my um, my my simulation
We are
has
getting nothing from your
ran
end, please.
successfully
If you can
and
hear us,
everything
we are
is
getting nothing, neither
has been
sound nor
calculated.
energy.
He said, Can you guys see my screen now? Can you
Yes.
guys see my
Yes.
screen now?
Yes, I can.
Okay. So you can see that from this now. Let me see if I can. Okay. So all my every component of this has has been defined. Everything is on blue. Coming. So this is how, if yours is showing something different, one of these is not showing, one of these components is not showing, what are they calling it? Um, one of these components is not blue. Just know that you haven't defined that component yet. Okay, I'm coming. Give me a minute. Um, someone wants to join this call. I need to send in the link. So far, does anyone have any question? Like I said, Aspen Hysys
So the
isn't difficult,
between that,
isn't difficult at all to learn. Come again. Your line is breaking. I didn't hear what you said. I said your line is breaking. Does anyone have any questions
so I
so
Sir,
have a
far?
evening,
question.
sir. Please, something you did. Hello, are you hearing me, sir?
Yeah.
Y- yes, sir. Yes, sir. Yeah,
Yes, yes.
from what you did, though the network didn't allow us to
You
actually
said
know
there's
what
something
you
I
did
did.
at the pump. The
Okay.
Yeah, that there's a parameter you choose for the pump to turn on to to function very fine. We didn't see it. We didn't because you went offline,
Calculate.
so we didn't see it. Yeah,
Okay,
you were talking
okay.
about pressure, the parameter.
Okay. Okay.
Mm.
Okay. So for this, let me go back there. So this was how this was showing initially previously. The This outlet was not defined. It wasn't defined. So we needed, if you look at, hold on, someone wants to join this call. if you, from what I explained about your equipment being fully defined when carrying out a simulation in Aspen Hysys, you can see that this our pump equipment, our pump is not um, our pump has not been defined. You get, because one way to know that you can see our pump out is on sky blue, not on dark blue, and you have a stroke around it on blue, sorry, yellow. You can see all these other ones, the stroke is black, has a black stroke. So using the color notation, you will know that this equipment has not been fully defined. So in order for us to define it, I'll double click on it, come to parameter. Now I have delta P, which is talking about the pressure change. So when we are talking about pressure change, it's either the pressure is decreasing or is increasing. So what is it changing from? Is it changing from 100 to 110, or is changing from 100 to 90? But definitely, as using a pump, you are actually increasing pressure. So it is either you define it in ratio or you define it as delta P. So for this, I defined it in ratio. I just use ratio of 2 and hit enter. It automatically calculated that. And you can see the pressure change here, 100 psi, close. So you can see that it's fully defined. This whole system, this whole simulation we just carried out is now fully defined. And this is it. So basically, this is how, like I said, Aspen Hysys is complex at some point. Maybe when you start using heat exchangers and some other advanced tools, uh, fractional distillation column. But like I said in the previous class on Wednesday, or like I said in the previous class on Wednesday, Aspen Hysys